We're now going to look at some different finance formula that we'll use later on. Now, the first type of finance formula that you probably saw was this simple idea of simple interest. There are different forms of it. What I've put down here is I equals PRT, I standing for the simple interest, P being the principal, and interest rate, but written as a decimal or a fraction. And T, of course, is time. So, okay, $3,000 invested for 7 years, 6% simple interest. How much will it be worth after 7 years? So I equals PRT. So principal is 3,000. Our interest rate is 6%, but I'm going to put it as a decimal, 0.06. And time is 7. Multiply it all together, and there's our answer, 1,260. Well, it's our answer to the interest. It's not an answer to the question. The question said, how much will it be worth? So to find how much it's worth, we'd have to add the interest on to 3,000. So $4,260 after 7 years. I mean, it's called simple interest because it's a very simple idea. In reality, that's not how interest is charged on investments and things like that. That's where we move on to compound interest, which is more realistic. And here's our formula. Amount N is PR to the power of N. And what you'll notice here is that it looks very much like the general term of a geometric series. Hence why this application is in our topic on series, because it is a geometric series. Amount N, so after N time periods, what's it worth? So this is the initial investment and interest rate applied to it as well. P is the principal, that initial amount. R, now the interest rate this time is 1 plus the interest rate. Again, as a decimal or a fraction. N is our time periods. Now, the important thing with compound interest is we must make sure the interest rate and the time periods are using the same units. So you go with whatever the compounding. Compounding annually, per annum. Compounding every 6 months, then you want to know interest rate per 6 months, and so on. So same investment, $3,000 invested for 7 years, but this time compound interest. And first of all, we'll look at compounded annually. All right, let's sub in 3,000 for the principal. It's 1 plus the interest rate, so 1.06, 7 years, and you'll see we get 4,510.89. So compound interest is always going to pay more than simple interest because you're getting interest on your interest. It's compounding, hence the name. Well, what about if instead of compounding annually, we went and compounded monthly? So same formula, but this time amount N, it's not 7, we got to convert it to months, whatever we're compounding. So we're compounding monthly. 7 years is 84 months. And the interest rate was 6% per annum, would be 0.5% per month. So 1.005. And we get slightly more. And obviously, the shorter the time period you're compounding, the more your investment's going to grow to. What about this idea of depreciation? Depreciation and compound interest are basically the same things. Hence, it's the same formula. PR to the power of N. Amount N, yes, P is still the principal, but here's the difference, the interest rate. Because depreciation, the value is going down, we go 1 minus the depreciation rate. Again, as a decimal or a fraction. And this time periods, also just like compound interest, because as I just said, it's the same thing, you got to match the depreciation time. So an espresso machine, so some sort of coffee machine, must be an industrial one or something for $15,000, but it was bought for $15,000 on the 1st of January 2001, and it depreciates at a rate of 12.5% per annum. What's its value going to be on the 1st of January 2010? So there's our formula. Sub in. So 9 years. 15,000 is our principal. 1 minus the interest rate. So 0.875 to the power of 9. So it was $15,000, but after 9 years, it's now only worth about $4,500. So when will the value drop below 10% of the original cost? So when is that amount N going to be less than 1,500? 10% of 15,000. So it's N that we're trying to find. Got to solve this inequality. Well, let's divide both sides by 1,500 and exponential to solve. So log both sides. That allows us to bring the N out the front. Divide by log 0.875, but remember, log of a number smaller than 1 is a negative number. So when we're dealing with inequalities, divide by a negative number. If you change the sign, you change the sign. And we get N is greater than 17.24. So it must happen during the 18th year, because when it hits 17, there's still a bit to go. It's still got that 0.24 and so on. So 2018 will be when it will drop to 10% the original cost. All right, let's have a go at 14C, applying these different finance formulae.